Hey everyone, welcome back to The Explainer. So today, we're zeroing in on May 14th. Now, you might just think of it as, another totally normal day on the calendar. But May 14th is actually one of the absolute greatest dates in the entire history of math. It's literally a golden day. We're going to explore exactly why that is, and honestly, trust me on this. By the end of this explainer, you are never going to look at your smartphone the exact same way again.
So check this out. On this one single date across totally different centuries and completely different countries, some incredibly brilliant minds were either born or passed away. But they all share this amazing connection. From 1761 to 1917, all the way to 2014, these specific individuals completely changed the world we live in right now. Looking at their stories, it's kind of like opening up a detective file on the modern world. So let's meet them one by one.
But real quick, before we drop our first name, I want you to think about a modern wonder we all just take for granted. Have you ever wondered how your encrypted WhatsApp messages stay completely safe? Like when you send a super private text or maybe a bank password, it travels through the airwaves, yet literally nobody else can read it. How in the world is that actually possible?
Okay, let's dive into this. The answer actually traces all the way back to May 14th, 1917, and a guy named William Tutte. Tutte was this unbelievably brilliant mathematician who found himself stationed at the famous Bletchley Park during World War II, literally surrounded by the greatest codebreakers of his entire generation. So, during the war, the German army was sending out these highly complex, encrypted messages that were known as fish. And Tutte did something that is just, well, it's astonishing. Just by staring at the patterns in these intercepted, scrambled characters, he deduced the exact mechanical structure of the machine sending them, a machine with 12 wheels that he had never, ever laid eyes on. He then wrote decoding algorithms that were so insanely complex, an early computer called Colossus actually had to be built just to run them. The foundation he built for making and breaking complex codes, yeah, that is exactly how we keep our digital data, like those WhatsApp messages, totally secure today.
And this brings us to a massive light bulb moment. Tutte took a seemingly impossibly difficult task, and he solved it by finding the hidden pattern. Finding the hidden pattern in all of that chaos is the absolute root of modern data encryption.
All right, same date, but let's jump way back in time. And again, before we meet our next genius, let's ask another very modern question. How do video game physics engines calculate movement so incredibly fast? Like when a car crashes or a character jumps on your screen, the software behind the scenes is doing incredibly complex math in literal milliseconds just to make it look real. How does our software pull that off without just freezing up?
Well, the answer actually goes all the way back to May 14th, 1761. That's the day Thomas Simpson died. And Simpson's story is just amazing. He had very little formal education. The guy was actually a self-taught weaver. There's even this fantastic kind of wild historical anecdote where he had to flee his hometown and move to Derby after frightening a girl by dressing up as a devil during an astrology session. I mean, you can't make this up. But anyway, he eventually made his way to the coffee houses of London, started teaching mathematics, and became an absolute master of the subject.
Now, what's really interesting here is what this self-taught weaver actually created. He developed these incredible numerical methods to calculate complex curves and areas. In fact, today we still use the modern iterative method he championed for solving really difficult equations. It's essentially a brilliant mathematical shortcut to get incredibly close to an answer incredibly fast. And it's his math, these super fast, reliable approximations, that secretly powers the blazing fast computing in all our modern software today.
So, the very next time you boot up a video game, just remember this. Every fast calculation on your screen is secretly built on centuries-old numerical approximations. Thomas Simpson proved that you don't always need to calculate out to infinity. Sometimes you just need a remarkably smart shortcut.
All right, let's keep this moving. One date, so many crazy stories. Think about this for a second. How do our computers translate complex languages and decipher hidden signals basically instantly? Like if you just point your phone camera at a street sign in a completely unknown language, it translates it right before your eyes. How do we make sense of the completely unknown? For that, we look to May 14th, once again, specifically the day we lost Murray Macbeath in 2014. And to really understand his impact, we have to return to the Bletchley Park era of World War II. Macbeath was this brilliant young man who came in with a first-class honors degree in mathematics, and he was assigned to Hut 7. His main target? The highly complex Japanese Navy codes. So the crucial point is that to crack these specific codes, Macbeath realized he couldn't just rely on numbers alone. He had to actually become fluent in Japanese. He completely mastered a foreign language just to find the tiny vulnerabilities hiding in these seemingly unbreakable ciphers. He really showed us that the ultimate tool for decoding the unknown isn't just math, and it isn't just linguistics. It's the incredibly powerful combination of both. And honestly, it's that exact same logic that powers the translation and artificial intelligence algorithms we use on our smartphones today.
And that leaves us with this final, incredible realization. The ultimate codebreakers didn't just understand math, they understood the language of chaos. Macbeath found a logical structure inside something that, to anyone else, just looked like completely random noise.
So let's move into our final wrap-up section here. The pattern inside chaos. What connected them all? If we look at our timeline again, Thomas Simpson in 1761, William Tutte born in 1917, and Murray Macbeath passing away in 2014, we're seeing people from entirely different eras, right? They were facing entirely different problems. Yet, they all did the exact same fundamental thing. They looked into the dark and they asked, what pattern is hiding inside this chaos?
And this brilliantly illustrates their shared legacy. Thomas Simpson looked at complex, seemingly unsolvable curves, which is a true mathematical chaos, and he found the pattern of numerical approximations. William Tutte stared at a wall of scrambled, encrypted fish messages and somehow pulled out the pattern of a 12-wheel machine. Murray Macbeath looked at unknown, constantly shifting Japanese ciphers and found these brilliant linguistic mathematical keys. Because they were curious enough to find order in the chaos, our world today has ultra-fast software, safe digital messaging, and instant translation.
So as you go about your day today, using your GPS, streaming your favorite music, or sending a secure text to a friend, I really want you to remember May 14th. And I want to leave you with one final thought to ponder. The next time you face a problem in your own life that just seems completely impossible or chaotic, ask yourself, what is the pattern hiding inside the chaos? Thank you so much for joining me for this explainer. If you enjoyed discovering the secret history behind your everyday tech, please make sure you hit that like button and definitely subscribe to Maths Made Easy Suresh for more incredible stories from the world of mathematics. Keep questioning, keep learning, and I will catch you in the next